Good afternoon, everyone. Thanks for joining today. We're talking about our next generation radio called the Quantum. And what it is, it's the next generation of our wireless radio that combines what we do with the Condor line as a gateway, a protocol converter, IO repeater. But because we have a Linux memory area, we can add a code assist to create a controller. So it'd be a powerful IoT edge gateway solution. Also, from our Condor line, we can communicate licensed and unlicensed wireless technologies. But with the Quantum, we can add newer technologies like LoRaWAN and 5G cellular. We could do the mesh point-to-point and point-to-multi-point as we do with the Condor. We're going to do the same thing with the Quantum. We also have a proprietary method of passing data between hardwired communication protocols and also wireless using our what is called IO mapping within the Condor line. So we're going to be able to do the same thing in the Quantum, but we'll be able to do that over the newer technology, wireless technologies like LoRaWAN and also the cellular. The Linux memory area will be able to have the core Linux operating system, but then we also will be creating a Docker container to where you can add whatever type of Docker into the Quantum. So as of right now, we're going to be doing Node-RED on our core Linux area, but then with Docker, you can add code assist to create a controller, or you can add other types of technology like cyber secure solutions. And for those, we will have a key for some of them for additional costs to have that capability. The key features, just like with the Condor, we can do Pro Mesh. So each one of the radios can be a repeater to itself. It can be an IO radio or a gateway. It uses that IO communications at a patent for us, where we could do change of state and network update time. And over the air, just like the Condor, we'll be able to do the full IP communications using 802.11 to be able to do TCP and UDP. And for security, we have 3 stages of security with AES 250 encryption. But then, as I mentioned, with the Docker, we can add advanced security protocols. With the protocol conversion, with the Condor, we can do TCP, RTU gateway, DNP3, and MQTT native and SparkPlug-B. But with the Quantum, we're going to be adding the Ethernet IP, Profi, BusDP, and Profinet. With expandable IO, we'll be able to use the existing IO, the 11, 12, and 13 if you need additional digital IO or analog. For the frequencies, as we can on the Condor, we could do licensed, unlicensed frequencies, short and long range Wi-Fi, but we're going to be adding the LoRaWAN, Heart over wireless, where we can do that with the Condor, but we're going to be expanding it with the Quantum and then Bluetooth. Dashboards right now and the logic engine are very simplistic. We're going to be able to do the same thing with logic and the dashboards with Node-RED. So here's the list of the Condor key features. We're going to be able to do everything that is listed here. I also included our cellular modem because with the Quantum, we're going to be able to do a cellular modem built into it. But as you see, we go from a 115, which is no wireless, 215, 925, which is unlicensed, 900, 415 with license, and then For future, we're going to be able to do the 415U1, which has a enclosure with a solar controller built into it, but that's not on the horizon yet for quantum. And in the 641M2 and 4, which will be built into the quantum. So if you see the features, we can do the discrete and analog and pulsed ins and outs, Modbus gateway, MQTT, Spark-Plug-B, broker and client, store forward, that logic and HMI that we have as IO plus in the dashboard for the Condor. And then depending on the unit, the 215, the 641M can do high Wi-Fi hotspots. So if you look at the quantum features, it's we have a base model and a more advanced. So if you look at the base model, it's similar to the 215 unit, which has the short range Wi-Fi. On the IO, we added 2 additional analog inputs, and we added HART on all the analog and multi-drop HART on all the analogs, including the analog outputs. To do the Modbus gateway, the MQTT, we're going to be able to do a broker within the quantum. Store and forward, as I mentioned before, the node red for the logic in the dashboard. This Linux area that will be able to run custom applications. We call that bring your own application. And in the future, we'll have a Docker to where you can add a Docker internally to it. Protocol conversions, we have the MQTT and DNP3 and Modbus, but as I mentioned before, we're going to be adding Ethernet IP, Profinet, and Profi plus DP. With the advanced features, we can do everything that you can do on a base unit, but they have 3 slots to where you can add different wireless or cellular communications. So the first slot would be to where you would pick between long range Wi-Fi, where it's 900, 2.4, or 5 gigahertz, license frequency, which is 150 to 900, and then an unlicensed 900. On slot 2, you pick between the LoRaWAN. We're looking to do wireless HART, but we haven't found the card yet that would integrate into it. Slot 3 would be for the cellular. So we have 4G, 5G, and then at the moment AT&T FirstNet, and they do have a comparable system like that for Verizon that we're looking into. So if you look at the hardware layout, the front of the unit, well, first of all, the processor is 1 gig, so it's much faster than the existing Condor. It has 2 gigs of RAM, 8 gigs of flash, and then they have expandable SD slot that is on the front of the unit right here. Wi-Fi, I already went through that, so where we could do Wi-Fi, licensed and unlicensed, and then also cellular. So on the top part of it, they have all the ports for the wireless connections. So SMA connections. We have 3 Ethernet ports, 1 on the front, 2 on the bottom. The communication port, which is a USB version B, would be more for data logging. The programming port, the USB-C, is used for programming. We have ID indication, LED indication lights for the I/O, which, as I mentioned before, we added 2 additional analog inputs to the Quantum compared to the Condor. It also, in this terminal block, is able to connect to a RS-232 or RS-45 COM serial communications. It is a Class 1 Div 2, like the Condor. Same configuration for the power at the bottom, where you have a connection for battery and also for supply voltage of 24 volts. This area right here is a switch. If you use an RS-485 and it's the end of the network, they have a switch for the resistor. And in this area would be 2 slots for the SIM card for the cellular. So for the program structure, as I showed, mentioned already, we added 2 analog ins. So you can bring in analog, you can bring in RS-232 and RS-485, bring in Ethernet, and also the wireless. And that proprietary protocol that I mentioned is able to configure this and be able to pass data in and out of all these different ports in I/O from the middle area, which is the memory. But what we did add, as I mentioned earlier, is that area of Linux. It's based off of the ARM 64 processor. Here is where, with the bring your own application, we're going to start out with running Node-RED. And then if you have any custom application, you can run it in that area too. But when we do have the Docker container, you could use Code Assist, you can use Ignition, Rockwell's Optics, whatever is pre-written to run on a Docker station for the ARM 64 processor, which is the same as what you would get with other gateways, edge gateways. So protocol conversion over serial connection in Ethernet will be to where we're adding the Ethernet IP, Profinet, and Profibus TP. The expansion, we're going to keep it the same to where we can use the 115S serial I/O cards that we have out right now used for the Condor radio series. So within the memory, we're based off of Modbus. We're going to be able to expand that to more memory within the unit. As I showed on the last slide, the Linux area is where we could actually add additional security, advanced cybersecurity as a Docker. Within diagnostics, we can pull, just like the Condor, internal status IO and create a dashboard with Node-RED, and you have access, like with the Condor, to get the battery, the voltage expansion, the RSSI, comms fail. So with the slots, as I mentioned before, we have the internal radio for the base and the advanced, where it's short range Wi-Fi. Slot 1 can communicate long range Wi-Fi at 900, 2.4, and 5. License from 150 to 900, and unlicensed spectrum of 900. Slot 2, as of right now, is more for LoRaWAN. Future, maybe wireless HART. And slot 3 would be cellular, where we have the 4G, 5G, and AT&T, and we're investigating the Verizon equivalent to the AT&T FirstNet. And as we do with the Condor, we're going to be able to do the mesh network, where each radio can be a repeater to itself, and be able to configure the fixed link and manual. So this is a conventional wireless network architecture, to where our Condor can do this, but other competitors may not be able to do I/O at a location. So you would have to add that to communicate over usually a network using Modbus over the air. Same thing over here, you would need to have a data converter to convert the protocol from whatever protocol it is to be able to pass that through the air. And then over in this area where you have your base radio, you may need, for competitors, add a repeater, but with the Condor, it's all built into one. But with the Condor, we would have to add a cellular router if you were to want to communicate up to the cloud or a remote location. So with the quantum, we can do that all in one unit at each one of the locations. Use the newer technology like Node-RED if you have to massage data, be able to do the conversion of like Ethernet IP, Profinet, or Profibus, and then also at the central location, be able to have the option for the cellular to be able to maybe interface to a SCADA system up in the cloud. But on top of that, we can add within that Docker area a cybersecurity, more advanced security that you can have a more secured network through the air and then also at your SCADA system. So I'm just going to go over a few applications that you could do in a lot of cases Condor, but then do a better job with the newer radio, the quantum. So for water, wastewater, you have your central location, SCADA system, being able to transmit that to your plant or somewhere over the web, where you would put like a cellular connection, and then you would have your radio communicating out, gathering the data or controlling the pumps, looking at shutdown systems and leak detection, control of stations, sampling, and including doing video. So the processor that we selected for quantum is able to do video also. This same as that architecture that I showed you earlier, but it applies to a water wastewater application where you have a network of radios. Other than the Condor, you have to add a controller or remote I/O to get the I/O. The Condor can bring the I/O in. Same thing over here with the data conversion. We can do with the Condor just Modbus TCP. Or RTU, DNP3, and MQTT. Same thing here with the repeater, but with the quantum, we're able to do combine the functionality into one unit. Here is if you have like a remote location for a lift station, and you need to communicate over a cellular connection, you have a 641M using I/O Ethernet or via a serial with our expansion I/O, communicating over to the SCADA. But with the quantum, we can do that all in one unit, and then add expansion I/O if we need to, if we need additional I/O. So with the oil and gas application, similar to the water wastewater, where you have that central location at a well site or offshore, being able to have a cellular connection or satellite going to your remote SCADA system. And here you would be bringing in automation from an RTU or flow computer or PLC, the wellhead information from sensors, and then control stations, alarms and shutdowns. And as I mentioned earlier with the water wastewater application, you can do video because of the processor is much faster and more memory within the quantum. So for another example in oil and gas is to be able to communicate in a tank farm. You can do this with the Condor right now, but with a MUX, in this case, an MTL MUX, to where you could bring in your heart instruments and be able to put it into data mode or asset management mode. And you can have it for a standalone gateway, but then also be able to transmit that over a long range area of up to 20 miles to be able to communicate to remote nodes to a base radio. And what you can do that same functionality with the quantum. But with the quantum, because it has the heart built into it, you wouldn't need the MUX. It would bring the analog into the unit, convert it and be able to pass the data. And then because we have the 802.11 UDP, we would be able to do the asset management from FTT containers like Packware to be able to do asset management from a remote location up to 20 miles. This is an example of doing the same functionality, but having a wireless HART. Because we don't have the wireless HART module developed yet, we could use an Emerson gateway or an ENH, pull that data into the Condor or the Quantum, and be able to do those two same modes, the data mode and asset management mode. And that can be done over a long distance, up to 20 miles. So we could do the wireless HART over wireless. So data converter to where you have potentially want to get flow from one location to another and be able to transport that data across, and then be able to use a data converter as a dashboard. You can do this in Condor, but then also in the Quantum. And because I've done an application like this with a gateway that it's converting it from serial to Ethernet and pass that over the air and then convert it back from Ethernet to serial. That didn't have a, Phoenix contact converter wouldn't allow you to be able to look into the system to see the data. But because our radios has that dashboard, we were able to use it to troubleshoot and be able to see the data back and forth. Here's a cellular gateway using a flow computer where you would have a cellular router, a actual gateway radio, and then if you need additional I/O with the Quantum, we can do all that in one. With mining, this example of I think about 20 remote sites going through the data concentrator using one of our older radios, and then passing that to a gateway, then to a SCADA. You do that with a Quantum, but then you can also at the locations be able to bring HART in and then pass it to the SCADA system. Agricultural application where you have a lot of farm equipment that you need to look at different parameters from the farm equipment. This is a perfect application for LoRaWAN. So what we have is the capability of being building into the Quantum a LoRaWAN gateway. One of our partners has an application using Ignition where they have graphics built per an end device communicating LoRaWAN. What they can do is scan that device. It's in the database of the Ignition, and it passes through that data. You just have to add a gateway, passes that data through the Quantum, converts it to MQTT, and you can view it within Ignition. And it's a very quick application where you scan the QR code. It recognizes it within the Ignition application, and all you need to do is add the gateway, and it passes data back and forth. So that's an application, perfect application for a agricultural system, but it can be applied to multiple applications. Here's an application for Rockwell to build into their ecosystem. They have a Docker for FT. It's called Factory Talk Optics. You can add that into the Quantum, be able to communicate within the Rockwell system, where you can communicate OPC UA, MQTT, Ethernet IP, and actually have a headless graphics package built into the Quantum. This example of our gateway here but then internally to the bring your own application or the Docker, here's where the FactoryTalk optics would play. You could add Node-RED in this area, but we already have it in our core Linux area. But then you can also add other Dockers to communicate. Another example is with Siemens. If you need to communicate to Siemens, their terminology for their ecosystem is called MindSphere. And we're looking to be able to interface into their ecosystem too.